Hi, and welcome back for some sassy Terraform talk. No, not that kind of sass. Today we're going to be talking about software as a service. So today we're going to be looking at two popular SaaS platforms to manage your Terraform deployment workflows. Many organizations look to a management platform to drive their Terraform workflow as their teams grow and their infrastructure requirements get ever more complex. A platform like Terraform Cloud from HashiCorp aims to help users solve complex problems around development workflow, compliance and security, role-based access control, and maintaining standards and consistency in organizations and environments that are constantly evolving and growing. So today I'm going to talk about another platform in this domain, which is Spacelift. Spacelift is also a SaaS platform that aims to manage your Terraform workflow right from code development through to deployment and everything in between. So which is a better fit for you, Terraform Cloud or Spacelift? In this video, we're going to look at what these two platforms deliver, and we're going to dive into some of the core features of Spacelift and see how they stack up to Terraform Cloud. So let's dive straight in. But before we get into the core features of these platforms, there's one particular point that sets Spacelift apart from Terraform Cloud. Terraform Cloud is a platform provided by HashiCorp to manage your Terraform workflows. Not only does Spacelift drive your Terraform workflows, but we can integrate it with a variety of other tools as well, such as Pulumi, Kubernetes, Ansible, and CloudFormation. So with that out of the way, for this video, I'm just going to focus on the Terraform capabilities of Spacelift in comparison to Terraform Cloud. Let's start by looking side by side at a very high level, the differences between Spacelift and Terraform Cloud. The first things you're going to notice. So within Terraform Cloud, we have Workspaces. These are logical units that allow you to deploy a set of infrastructure with its own isolated state. They're made up primarily of the Terraform code that you want to deploy, which is normally pulled from a version control system, any input or environment variables that are needed for your Terraform code to run, and most importantly, an isolated state. So this allows us to take our Terraform code and deploy multiple instances of it. Each of those instances can be configured differently, and importantly, they all have their own state files, so they're all isolated from each other. A common practice would be to have all of your Terraform code in a VCS repo and then deploy instances of it depending on your environment. So an instance for production, an instance for development and staging, for example. The Workspaces is where it all starts in Terraform Cloud. In Spacelift, we have the concept of stacks. Spacelift stacks at their core are very much the same. We use them to tie together Terraform code with environment variables with an isolated state. So they both serve the same purpose of organizing and managing our infrastructure in an isolated way. Stacks in Spacelift boast some impressive features such as protections in place to ensure that multiple people working on the same project don't run into each other. In Spacelift, state locking is integrated into the GitOps workflow and applied at a stack level. And that means users are prevented from starting concurrent runs and causing state locking problems. This promotes greater collaboration when multiple teams and multiple engineers are working on the same projects. Another powerful feature we get with Spacelift stacks is stack dependencies. Larger, more complex deployments may have a variety of interdependent resources or components and services spread across multiple stacks. In Terraform Cloud, the ability to intelligently create dependencies between different workspaces is kind of loosely coupled and not easy to define. With Spacelift, we can easily define trigger dependencies and use code to define how and under what circumstances different stacks are triggered based on the outcome of other stacks. This gives us much more control over large, complex deployments that have many interdependent parts. So far, we see the similarities between workspaces in Terraform Cloud and stacks in Spacelift. One thing we mentioned before that they both do is manage Terraform state. But there's one big difference between Terraform Cloud and Spacelift when it comes to state management. So like Terraform Cloud, Spacelift can manage your state for you. You don't have to concern yourself with setting up cloud storage, with access, with security, and managing all the infrastructure around that. Spacelift can handle all of that for you. However, unlike Terraform Cloud, Spacelift gives you a choice. Yes, Spacelift can manage your state for you, but if you choose to manage it yourself, if you want to keep your state in your existing S3 bucket, for example, that's perfectly possible with Spacelift. So you're not locked into having to have Spacelift manage your state if you don't want to. So we've looked at the basics of stacks within Spacelift. As we said, a typical setup might be to take a Terraform model from your VCS repo and deploy that out to 2 or 3 different stacks, maybe development, staging, and production. But for larger organizations working with multiple teams, it's not uncommon to have to deploy tens or even hundreds of stacks. Maintaining standards and consistency across all of those stacks when they've been defined in an organic way is a huge problem. Spacelift addresses this problem with blueprints. With a blueprint, you effectively create a reusable template that allows you to dynamically generate consistent stacks with overridable attributes. And the best part is that blueprints themselves are written as coded templates in YAML. So with Spacelift, the stacks themselves can also be managed as code. So we've looked at Terraform Cloud Workspaces and how they compare to stacks in Spacelift. So now let's go beyond the stack and have a look at the execution model itself. And by that I mean the runtime that is used to plan and apply your Terraform code and what control we get over that. With Terraform Cloud, you get a limited ability to customize your run using run tasks. This allows you to integrate a pre-canned task at the before or after stages of a plan or an apply. While this gives you some customization within your workflow, with Spacelift, however, you get complete control over your run. You can customize it in any way you want, and you can integrate any third-party tooling that you want into the run. This is made possible because the containers that Spacelift uses for your run are completely customizable. In fact, not only can you customize the container that Spacelift uses for your Terraform run, you can replace it entirely with your own container configured exactly how you need it. On top of this, Spacelift has 11 different integration points or hooks in your workflow. This means you can customize your Terraform plan or Terraform run at any one of these points along the way. We'll talk about this a little later on when we discuss integrating security tools into your Spacelift runs. So we've looked at stacks and workspaces, we've looked at the execution model. Let's take a quick look at how we integrate with our cloud providers now. So with Terraform Cloud, you can integrate with the cloud providers such as AWS by using environment variables to define, say, the AWS access key and secret key, much like you might do from a standard CI/CD workflow. Whilst you can still take that approach with Spacelift, a better way is using native cloud integration that Spacelift offers. With Spacelift, you can easily connect to your AWS account and have Spacelift assume a role within AWS. And then Spacelift will be given a set of temporary credentials that it can use for that run. Spacelift doesn't just have native cloud integration to AWS, it also supports Azure and GCP in very similar ways. So at first glance, after a brief overview of Terraform Cloud and Spacelift, we can see some key differences already. We can use Spacelift not only with Terraform, but with other infrastructure as code tools such as CloudFormation, Ansible, or even Kubernetes. Spacelift can manage your Terraform state, but you're not locked into that if you choose to host your state somewhere else. Integration is almost limitless thanks to multiple integration points and fully customizable runtime environments. And with Spacelift, you also get the benefit from native cloud integration. So we've had a look at the basics between these two platforms. Let's dive into an area which is of great importance to many people and a reason why a lot of companies move to these types of platforms, and that's compliance and security. One of the key reasons that many organizations choose a platform like Spacelift or Terraform Cloud is the need to secure their Terraform deployments and ensure that all the guardrails are in place to maintain compliance and standards. Relying on manual review to make sure that our workflow meets these requirements is not good enough. What infrastructure as code management platforms do is give us the ability to codify these policies, to write them down, so we actually have policy as code. And then we can make sure that these policies are applied and enforced at different parts of our workflow. Both Terraform Cloud and Spacelift have the ability to define policy as code. We can use policies to place guardrails around Terraform by inspecting plans and then denying or allowing those plans to run based on the outcome of the policies. With Terraform Cloud, we're able to attach these policies at the beginning or at the end of a Terraform plan or a Terraform apply, giving us a pretty good enforcement of policy at that level. Spacelift does this and more. With Spacelift, we can apply these policies to 11 different points during the lifecycle of a Terraform run. And with Spacelift, we can apply policies to a whole lot more than just a Terraform plan and Terraform apply. In fact, using Spacelift, we can enforce policies at nearly all decision points within the application. So we've just discussed plan policies that deal with Terraform plans and Terraform applies, but Spacelift has many other types of policies that operate in other key areas of our workflow. We've got login policies that can be used to define which users can log into Spacelift and what overall privilege they get. Approval policies can be used to enforce sophisticated tailored review and approval chains in our workflows. We can use notification policies, customize the visibility we have to certain events within Spacelift, and we can dynamically route those notifications internally or to a Slack or Teams channel thanks to Spacelift's native integration, or to any other tool using an external webhook. Plan policies, as we've already discussed, can be used to inspect a Terraform plan and allow or deny that plan to proceed based on predefined criteria. With plan policies, we can inspect the actual resources that Terraform is going to deploy, and therefore implement guardrails to ensure that all of our organization's rules and practices are being complied with. Push policies can be used to fine-tune and customize our GitOps workflow. This is a really powerful feature of Spacelift that we're going to cover very shortly. And we also have trigger policies, which we can use to define relationships between stacks. Remember earlier when we said that stacks can have interdependencies and we can have relationships built on top of that and dependencies between stacks. Trigger policies is how we make that happen. So policies are the main driving force behind Spacelift and its biggest strength by far. The fact that we're able to use so many different types of policies and in so many different places in our workflow and in our application is what really sets Spacelift apart. You have the control to fine-tune and customize all of the decision points within the application to meet your organization's requirements. And for larger companies or companies operating in a regulated environment, this is a must-have. So we've looked at policies as a way to introduce compliance and governance within our workflow, but now let's take a closer look at security and how we can use policies to integrate third-party security tooling into our workflow. Spacelift gives us even more flexibility around ensuring security standards thanks to a feature called custom inputs. And when we combine plan policies with custom inputs, we're able to integrate with any third-party testing or security tool with total freedom. So let's take a look at how this would work in practice. If we want to run a security tool like TFSec or TerraScan, we could just drop that into our own image if we're using our own image for a runtime. Or we can use Spacelift's runtime hooks to run the appropriate commands to install the security tool at the beginning of our plan. Then we can use those same hooks to run our tool to perform some tests, to do some security vulnerability scanning. Later on in the process, when we apply our plan policies, the data that we have in that JSON file is available, and we can ingest that data into the policy and then make decisions based on the output of our security tool. This level of flexibility makes Spacelift so customizable. You can integrate with any tool that you want at any part of the run. So you get complete control of how you want to test, scan, and validate your Terraform plans before they're approved. Spacelift excels by using policy to enforce compliance and rules across all areas of the platform. Couple this with custom inputs and you get a far superior level of flexibility when it comes to fine-tuning your workflow and your security needs. So now let's see how Spacelift and Terraform Cloud stack up when it comes to GitOps workflows. Both Terraform Cloud and Spacelift can be used with all the major popular VCS tools such as GitHub, GitLab, Bitbucket. I'm going to focus on perhaps the most popular one, which is GitHub. Terraform Cloud and Spacelift both offer native GitHub integration with a marketplace app that can be connected directly to your GitHub account. Spacelift also gives you the option to initially sign up using your GitHub account. And doing this will mean that the integration is automatic and done for you as soon as you create your Spacelift account. You can also choose to limit access to certain repositories or open up access to every repo in the organization. Both platforms integrate very well with GitHub and are able to trigger events such as Terraform plans or Terraform applies directly from actions that take place within GitHub, such as raising a pull request. Spacelift, however, brings a lot more to the table. It aims to be completely GitOps native and give you really powerful tools to manage every part of your Git workflow. It does this thanks to one of its most powerful features, which we're going to talk about now, push policies. So whereas plan policies allow you to take decisions and enforce compliance in your Terraform plans, push policies allow you to do the same within your GitOps workflow. And we can use them to fine-tune all of the processes that your teams use to develop and commit code into your Terraform repository. So we can use push policies to add a layer of compliance and governance at this level before a Terraform plan is even considered. Push policies can be enforced whenever there is a git push or pull request initiated in your Git repo. And then we can deny or allow the triggering of a Terraform plan based on the outcome of those policies. This gives us the ability to be truly GitOps native and fully customize our GitOps workflow, add security and compliance checks before code is accepted, and define customized approval and review chains, aiding in efficient collaboration and code review. All of these can be fine-tuned and tailored to your organization's requirements thanks to push policies. So while Terraform Cloud gives you integration into your VCS repo to tie the components of your deployments into the platform, Spacelift gives you a truly native GitOps workflow with the ability to customize and define your own processes that fit your team's needs. So we can achieve maximum collaboration while maintaining governance and compliance, and have confidence that we have all the necessary guardrails around our code. Next up, we're going to have a quick look at user management and role-based access control. Both Terraform Cloud and Spacelift offer a variety of features for user management and role-based access control. It's an essential requirement when managing large infrastructures, and it's one of the main reasons that many organizations choose to adopt an infrastructure as management platform. Terraform Cloud allows you to split up your workspaces into different organizational units, each with their own set of permissions for users, and users can be divided up into teams to make managing access rights simpler. That's certainly useful, but still quite limited compared to the granularity of control that Spacelift gives you over user access management. To understand how Spacelift really stands out in this field, we need to look at login policies and spaces. Remember when we were talking about the many different places within the Spacelift application where we can apply policies? Well, login policies are one of them, and we can use these policies to enforce security measures and access control during user authentication. Login policies in Spacelift allow administrators to define specific rules and restrictions that must be satisfied in order to allow a user to log onto the platform. These policies could include, for example, a requirement for multi-factor authentication, IP whitelisting, password complexity. We can apply these policies either to the entire organization or to a subset of the organization. And the way Spacelift allows you to split up your organization into manageable logical units is through a feature called Spaces. Spaces provide us with a way to completely isolate various elements within Spacelift, such as stacks, policies, cloud integrations, all within its own segregated silo. We can assign admin access to certain users only to certain spaces, and that makes it really easy to have granular permissions tailored to your organization's specific needs. Spaces can also be laid out into a hierarchy. So within Spacelift, we can define a hierarchy of spaces. Each child space within the tree is able to inherit configuration, variables, policies, and workflows from its parent state. We can then give admin access to a specific user to a specific space, and that user will be able to administer that space and any child spaces from it, but won't have access to administer any space in any branch outside of that. So Spacelift brings a lot to the table for larger organizations with multiple teams working over many different projects. By using a combination of login policies and spaces, we can ensure segregation of resources, we get role-based access control, and we get a flexible way to organize all of our configuration to avoid complexity and duplication. One last technical point that I want to talk about in this video is using the Terraform module registry feature. Both Terraform Cloud and Spacelift offer a module registry where you can upload and version your Terraform modules and providers and make those available to your projects. The module registry in Terraform Cloud is basically a private walled-off version of the public registry. It helps organize and version your Terraform modules and providers and then ingest those into your internal workflows. And we have a minimal set of features that define how they can be used. In Terraform Cloud, you're responsible for ensuring that your modules are stable by implementing a test framework in a CI/CD platform such as GitHub Actions. Spacelift, however, adds a layer of sophistication to the module registry that gives you a complete CI/CD solution tailored for your modules straight out of the box. With Spacelift, we can define a series of tests that will create and destroy all of the resources that your module defines in an isolated test framework. This gives us a lot more confidence that a new version of a module is stable before it can be consumed by any of the stacks. On top of these test cases, we also have policies that can be applied directly to modules. That's right, we can apply a policy to a module much in the same way as we apply one to a stack. We can use policies to ensure compliance and check for security violations in our modules in the same way as we do for our native Terraform code in our stacks. Also, not only can we apply tests and enforce policies to modules, but we can also set up dependencies between stacks and the modules that they consume. We can automatically trigger a stack to run if a dependent module in the module registry is updated. So again, Spacelift is all about giving you the control to deploy with confidence, and that's no different with the module registry. So we've looked at the feature differences between Terraform Cloud and Spacelift. Let's now have that conversation and talk about pricing models. Starting with Spacelift, we have a pretty simple two-tiered pricing model with a cost incline in the paid tier directly tied to the number of users. Spacelift has a pretty generous free tier where you get most of the functionality that we've discussed in this video, and you can deploy unlimited resources. You're free to write as many policies as you want, whereas with Terraform Cloud, you're restricted to just 5 policies in both their free and standard tiers. And while there are some policy types that are only available in the paid tier on Spacelift, planned policies are included in the free tier. So the paid tier offers the full feature set and costs as little as $250 a month, which also gives you double the concurrency of the free tier. You then pay a fixed $10 a month per extra user on top of the initial allowance of 5. So with Spacelift's simple tiered pricing model, you can budget your spend ahead of time. And that means you can plan for the future with a relative amount of accuracy. Terraform Cloud, up until fairly recently at the time of making this video, also had a similar pricing model based on simple tiers. However, recently, in a move that's caused a fair amount of chatter on the internet, they've completely flipped their pricing model to be on a per resource basis. This means instead of a fixed, predictable monthly fee, you now pay per resource that your projects manage per hour. Terraform Cloud still do have a free tier, but that's limited to just 500 resources. That may sound a lot, but remember that many things that we see as single entities are actually made up of lots of different resources. Every instance, every VPC, every S3 bucket are all resources. And when we start managing things like security group rules, these really start to stack up. This not only makes it hard to control and plan your spend, but given that Terraform Cloud defines per hour as being the time between creating a resource and destroying a resource, it's potentially a lot more expensive. So in this video, I've tried to highlight the main differences that Spacelift offers over Terraform Cloud. On the surface, they seem like very similar platforms, But as we dig deeper, we see where Spacelift really sets itself apart. In general, we lose some of that finer grained control when we move away from in-house solutions and move on to software as a service platforms. Spacelift aims to bridge that gap by providing a sophisticated, feature-rich platform, but handing you the keys to give you the autonomy and control to fine-tune your workflow. It does that using smart features and customizable policies that gives you the power to define all of the intricacies of your Terraform workflow, but does all the heavy lifting for you behind the scenes so you can focus on deploying your infrastructure confident that Spacelift has got your back. So I hope you found this video useful. If you have, then a thumbs up or a comment is always appreciated. If you want to see more videos around Spacelift and around Terraform in general, then please do subscribe to the channel because we've got many more coming. If you have any questions, then please leave a comment below and myself or one of our team will definitely get back to you. I'm Craig Dunn and I'll see you in the next one.